Okay, let's make sure, let's write this down. Okay, make sure you're writing this down in your notes. All right, this next part you're really going to need to write down because you have to know this next part when we get to it. Okay, but we're going to be talking about identifying polygons today. So finally, we're moving on. All right, we're moving on from triangles. We're going to polygons. Okay, you'll still see some triangles, okay, because a triangle is still a polygon, but we're going to be moving on into more sides of a shape. So that's what this chapter is going to focus on. Okay, so that's the definition of a polygon right there. It's a closed figure with 3 or more sides. So we got that right there. So make sure you write that down. And then we are going to discuss the names of polygons. Okay, I'm going to try to zoom out a little bit so we can see all of this. Okay. There's all of the ones. Yeah. You can write those numbers, but make that little table, okay, because we're going to write down the names of them. Okay. So write down that table, and then we'll fill in the names. You got 2 wrong. All right, let's talk. What is the name of a 3-sided polygon? Triangle, okay? We all know that, or we all should know that. Now, what about a 4-sided shape, and don't say square? It's a quadrilateral. Now, we will go more in depth in quadrilaterals because there's a bunch of different types of 4-sided shapes. Square is one of them. Rectangle is one of them. Trapezoids, parallelograms, rhombuses, kites. There's a lot. What about a 5-sided shape? Pentagon. What about a 6-sided? Hexagon. And no, 7 is not septagon. You are not the only one who said that. What's 7? Anyone know? It's not septagon. It just said that. It does not start. It doesn't start with this S. Heptagon. All right. What about an 8-sided? We should all know this. Octagon. What about a 9? Anyone know this one? It's not ninagon. It is nonagon. Nonagon. What about 10? Decagon. No. Decagon. Okay, we're going to skip 11 real quick. What about 12? What about 12? It is a dodecagon. That's 12. Because I said so. Now, this next part is going to include, all right, all numbers above 12 and 11. Okay? When we have a shape that has 11 sides or 13 or more, all it is going to be that number / gone. So it's going to be 11 gone. 13, gone. 27, gone. 12, you will see it as dodecagon. But because that's the name of it. Because that's the name of it. Because that's the name. There's probably an official title for those, but you're just going to see it as dash gone. Okay? So there is a name for 11-sided, 13-sided, okay? But you're just going to see it as 11 gone or 13 gone or 27 gone. Okay? Now, listen carefully. On this, all right? Maybe study these and know these names, because maybe you'll be given like a paper and you'll have to identify them. Maybe. Okay, so make sure you know these. Just make sure you know them. That's all I will say. Now, do we all have this written down? Okay, now, this next part, okay, we're going to be talking about identifying shapes, whether they are concave or convex. Okay, here are going to be some examples, so I would write these down. Or wait, oh no, I'm sorry. That's going to be the next part after this. Let's identify these two real quick. When we identify these two, what kind of shape is going to be the left one? It's going to be a pentagon. Why is it a pentagon? It's got 5 sides. What about the next one? Yeah, it's a nonagon. So how many sides does it have? 9. Okay, perfect. All right, you'll just see shapes like that. They're not always going to be perfect, okay, but it will look very similar to that. Here's the part about concave and convex. So if you want to go ahead and write that down, go ahead and write it down. All right, and then we will discuss this. So concave and convex is going to be right there. And I just realized on convex it says all sides are pushed in. It should say pushed out. Okay, so on some of these shapes, we're going to have to identify if they are concave or convex. All right. On the concave, okay, we got to pay attention because it only has to be at least one pair of sides is pushed in. So just think about those sides are going inside of the polygon. All right. And then it has at least one interior angle is measuring greater than 180 degrees. Well, when we have a side or when we have an angle that's 180 degrees, do you remember what that's called? It's not obtuse because there was a certain word that we said for 180. Anyone remember? That was when we had a straight angle. Straight angle was exactly 180 degrees. Okay. Well, on some of these interior, okay, angles of the shapes, one of the angles is going to be greater than that. Okay. So even though this doesn't really look like an angle, okay, that's on the inside, all right, and that angle is going to measure almost like 200 degrees, or it's probably greater than 200 degrees, okay? And we'll be able to see more with that when we go into solving the interior angles and the exterior, okay? But those angles are greater than 180, so it makes it concave. Now, a convex is going to be your typical shape that we have right here, okay? That's a hexagon. These are both hexagons, all right? All the sides are pushed out. All the interior angles are measuring less than 180 degrees, okay? So when we solve these interior angles, we're going to learn, all right, that the angles on the inside of these shapes are going to be greater than 180, and we're going to be able to solve those. Because those triangles were always exactly 180, all right? But the more sides we have, the larger those values are going to be. Okay? Do we all have this written down? Do we have questions on either of these two? Okay? All right, we just have 3 more words to pay attention to. So equilateral, equiangular, and regular. So go ahead and get these written down for these 3 shapes. All right, typically on the angle ones, they're not always going to be 90 degrees, okay? But just for these 2 examples, they have 90 degrees. Okay, so we already identified these triangles and have examples, but just know for an equilateral, okay, all the sides are going to be congruent, all right? And when we see this, those sides are all going to be marked. So they're going to have the symbol representing that they're marked and that they're congruent. Equiangular is when all the angles are going to be congruent. Okay, so all those angles are going to have the same exact value. All right, and then a regular polygon is both equilateral and equiangular. Okay, so we're going to be working with a lot of regular polygons because that regular is going to tell us that all those angles and all those sides are going to be the same value. So when solving for those angles, it's going to be important to know that, okay, they're going to be all the same value. All right. Does anyone have any questions? Okay. You got about 10 minutes. I'll let you work on the homework. It's pretty easy. But just pay attention on Friday. We'll also have time to work on the homework we have from this week.
Are you mic'd up, Andrew? Is that for like an audio lesson?
I
record all your lessons.